Hi girls, here's a quick video on what polar coordinates are so you can get started working on your daily work and kind of understand a little bit more about this before we start working with them in class. Let's see. So firstly, just real basic, polar coordinates are, the polar coordinate plane is similar to the Cartesian plane. The Cartesian plane is the plane that we've been using up until now, where you have an x-axis and a y-axis. Now we're going to start working with the polar plane, where your angle, you're going to, instead of having an x-coordinate and a y-coordinate, we're going to have an r and a theta coordinate. And we're going to use the trigonometry that we already know to find this r value and this theta value. So what we're going to do is first we're going to figure out, I'm going to explain where these polar coordinates come from. So for example, if we have, it's kind of a weird drawing. Well, no. Okay. If we are given the polar coordinates of a point are 2 and pi over 4, remember your r is 2 and pi over 4 is your theta. So essentially what you're going to do is you're going to rotate pi over 4 units, and then once you've rotated pi over 4 units, you're going to take 2 steps from the origin. 1, 2. And that's going to put your point right there. A rotation of pi over 4 units, and then you walk 2 steps away from the origin. Okay, so, for example, if you're asked to plot the point -3, that's a really bad one. Hold on. Hold on. Okay, so I'll fix this a little bit. First I want to show you how we would plot the point 3, 2 pi over 3, and then I'll explain how you would plot a point -3, 2 pi over 3. So if we're going to plot the point 3, 2 pi over 3, first let's acknowledge 3 is our r and 2 pi over 3 is our theta. So if we draw our axis, we are going to be rotating 2 pi over 3 units. So we're going to rotate to quadrant 2, which is where 2 pi over 3 is. So it's somewhere over here. And then we're going to start at the origin, and we're going to take 3 steps towards 2 pi over 3. So we're going to say 1, 2, 3. And so our point right here is going to be 3, 2 pi over 3. Because we started at the origin, we walked 1 step, 2 steps, 3 steps. And then we rotated 2 pi over 3 units. Okay, so we have a point, that would be the point 3, 2 pi over 3 on the polar coordinate axis. Now, if we wanted to rotate -3, 2 pi over 3, again, -3 would be our r, 2 pi over 3 would be our theta. So to draw our axes, what we'd want to do is whenever you have a negative r value, you're going to do the same thing. You're going to start at the origin, but instead of walking 3 directions towards 2 pi over 3, we're going to walk 3 steps away from 2 pi over 3. So again, let's rotate our axis 2 pi over 3, but we'll do a little dotted line here, and this is 2 pi over 3. Instead of walking 2 pi over 3 steps towards 2 pi over 3, we're going to walk 3 steps away from 2 pi over 3, which is in this direction. 1, 2, 3. And this is going to be our point down here in quadrant 4 as opposed to quadrant 2. So this point can be known as -3, 2 pi over 3, but it can also be known as +3, 5 pi over 3. Does everybody see that? Do you see that? That if instead of if our R value would be positive, then we could rotate 5 pi over 3 units and land right there, and then you would walk forward 3 steps to get to that point. Okay, so now let's do a couple of practice problems. If we're asked to plot these points, these polar coordinate values, let's practice this. Okay, this first one, 3, 5 pi over 3. This is what we just did, actually. We're going to be rotating 5 pi over 3 units, which is to quadrant 4. And then we're going to take 3 steps. Uh-oh, what just happened? Let's pause here. We're going to take 3 steps towards 5 pi over 3. So we're going to draw a line about 3 units towards 5 pi over 3, and our point right here is going to be 3, 5 pi over 3, because we walked 3 units, 2, 3. Okay, so now let's try 2 negative pi over 4. Let's draw our grid. And we need to, our R value is 2, and our theta in this case is negative. So first thing we want to do is we're going to rotate negative pi over 4 units. So we're going to be rotating in the negative direction. We're going to rotate clockwise. If we're just going pi over 4, we're going to go into quadrant 4. This way. And then if we want to walk 2 steps towards negative pi over 4, we're going to draw our line and start walking towards negative pi over 4 and go 2 units. And our point will be somewhere around here. This point would be 2 negative pi over 4. Okay, what if we have, whoa, let's pause this again, having some problems. Okay, so if we have a really simple one, and we just want to find the polar coordinates of 3, 0, we're going to draw our grid again, and remember 3 would be our R, 0 is our theta. So we want to rotate 0 radians, or 0 degrees. So rotating 0 degrees is just going to be along the x-axis, and we want to go 3 units towards 0 degrees. So we're going to start at the origin and take 3 steps in the 0 degree direction, and so this would be our point, our polar point, 3, 0. Okay, and then last one, if we have -2 positive pi over 4, again we're going to draw our grid. This time we're rotating, okay, so this time we are rotating in the positive pi over 4 direction. So first let's rotate our angle, pi over 4 units. So we're going to be going into quadrant 1. And now, draw a little dotted line here, we are going to be going in the -2 direction. So we're going to start at the origin and we're going to take 2 steps away from pi over 4. So we're actually going to take 2 steps into quadrant 3. So 1, 2. So this would actually be our point, -2 pi over 4. Do you see that? Do you also see that we could call this point +2 5 pi over 4? Because if you rotated 5 pi over 4 units, then you would be going in the +2 direction. Okay, so I'm going to go ahead and stop this video because we're getting up to almost 10 minutes here. I hope this helps, and I hope this allows you to start understanding what these polar coordinates are, how they work.